Bismillahirrahmanirrahim. My name is Julia Faz. I'm from BSPT. My topic is thermoplastic. What is thermoplastic? Thermoplastic are a class of polymers or plastic material that have the unique property of becoming soft and pliable when heated and then returning to a solid state when cooled. This behavior is a construct on of setting plastic, which harder irreversibly than heated. Inventor of thermoplastic. We have to go back to 1856 and Alexander Parkes of Birmingham, England. He invented the first thermoplastic and exhibited it at the 1862 London International Exhibition. This first plastic was given the name Pakistan. Introduction of thermoplastic. Thermoplastic are made by joining small molecules called monomers together to form long chain using a process called polymerization. A single polymer chain can be made from many thousands of monomers. The atoms in a polymer chain are joined by strong covalent bonds, whereas the positive chain are weak. Next is thermoplastic compound. Thermoplastic can come from both natural and synthetic sources. For example, some thermoplastic are made from cellulosic or cellulose fibers found in wood and cotton. Nylon, articles, and polymers come from petrochemicals, including petroleum and plant-based materials. Next is thermoplastic short information. Thermoplastic have a simple molecular structure comprising chemically independent macromolecules. They are softened or melted on heating, then shaped, formed, welded, and solidified when heated. Multiple heating and cooling cycles can be repeated, allowing process and recycling. Next is first thermoplastic. Celluloid, which is considered the first thermoplastic, made its appear in the mid-18th and ranged in the industry for approximately 100 years. During its peak production, it was used as a substitution for ivory. Thermoplastic invented. Thermoplastic arrived on the market when polyvinyl chloride was originally invented in 1872. It was not commercially produced until the late 1920s when the B.F. Goodrich company discovered a method of adding pasteurizer to the pressure hard material to make it more flexible and easy to produce. Next is chemical structure of thermoplastic. This is a chemical structure of thermoplastic. Next is characteristics of thermoplastic. The first characteristic of thermoplastic is reversible softening. Thermoplastic can be melted and reshaped multiple times without undergo significant chemical change. This makes them recyclable and allow for the various manufacture process like injection molding, exhaustion, and 3D printing. Next is linear or branched molecular structure. Thermoplastic typically have a linear or branched polymer structure. Next is which means the polymers chain can slide past each other when heated. Next is allow them to become malleable or molding exhaustion. Next is 3D printing. Next point is wide range of properties. Thermoplastic can exhibit a wide range of mechanical properties from flexible and transparent to rigid and heat resistant. Next point is the properties can be tolerated by selecting specific type of thermoplastic and by adding various additives or filters. Next point is recyclability. Because of their ability to be repeatedly melted and reshaped, many thermoplastics are highly recyclable. This makes them environmentally friendly compared to some other plastics. Next is application diversity. Thermoplastic find application in various industries, including aerospace, automotive, packaging, constructive, healthcare, and etc. Next is environmental benefits, recyclability. One of the significant environmental benefits of thermoplastic is their recyclability. Next point is they can be melted and reshaped multiple times without significant deterioration in their properties. Their recyclability can reduce the demand for new plastic production and minimize the accumulation of plastic waste in landfills and oceans. Next point is energy efficiency. The process of thermoplastic generally required less energy compared to some other material like metals. Low energy consumption during manufacture can result in reduced greenhouse gas emissions. Next point is lightweight properties. Many thermoplastics are lightweight, which can help reduce the weight of production and transportation, leading to low fuel consumption and emission in the automotive and aerospace industries. Next is environmental concern start. The contemporary environmental movement arose primarily from concern in the late 19th century about the protection of the countryside in Europe and the wildlife in the United States and the health consequence of pollution during the Industrial Revolution. Next is environmental concerns. The first point is non-biodegradable. While thermoplastic can be recycled, they are generally non-biodegradable when not properly managed. They can persist in the environment for the extended point, contribution to plastic pollution and harming ecosystems. Next point is resource intensive. The production of thermoplastic relies on the extraction and processing of thermochemicals, which are fossil fuels. Next point is this dependence on non-renewable resources contribute to carbon emission and depletes natural resources. Next point is chemical additives. Some thermoplastic may contain chemically additives, plasticized, or claim retardant that can be harmful to the environment and human health if not properly managed during disposal or recycle. Next is recycling challenges. While some plastics are recyclable, the recycling infrastructure and rate vary widely across regions. Inadequate recycling facilities and low rate of plastic recycling can limit the environmental benefits of thermoplastic. Next is ocean population. When improperly disposed of thermoplastic, production can end up in the waterways and oceans, contribute to ocean population and harming marine water. Next is recycling in thermoplastic. Recycling thermoplastic is an important way to reduce waste, conserve resources, and mitigate the environmental impact of plastic materials. Here's an overview of the recycling process for thermoplastic. First is collection. The first step in recycling thermoplastic is the collection of plastic waste. This can be done through curbside recycle programs, drop-off collection point, or specialized collection service. It's essential to separate different types of thermoplastic such as PET, HDPE, PC, PCV, and others as they may have distinct recycling processes. Next is sorting. Once collected, the plastic material are sorted based on their type, colors, and other characteristics. Next point is this sorting process helps ensure that only compatible plastics are processed together. Cleaning. To remove contaminants like grit, labels, and adhesives, the shorter plastics are cleaned. This can involve washing, hydring, and further mechanical or chemical processes to prepare the plastic for recycling. Next is shredding. The clean plastic are typically shred into small pieces, making them easier to handle and melt down in the recycling process. Next is melting and extrusion. The hardened thermoplastic are then melted or formed into petals or granules. This involves heating the plastic to its melting point and then forcing it through an extrusion process to create small, uniform petals. Next point is manufacturing new products. These plastic petals can be used to manufacture a wide range of products, including containers, packaging materials, automotive parts, and more. The specific application depends on the type of thermoplastic being recycled and its properties. Next is quality control. Manufacturers often perform quality control tests to ensure that the recycled plastic meets the required specification for the intended product. This may involve testing for strength, color, consistency, and other relevant properties. Next is Rio, Rios. In some cases, thermoplastic can also be reused directly, especially in applications where highly purity or specific properties are not required. This is common in some industry settings. Next is important note. Not all thermoplastic are equally recyclable, and the success of recycling programs can vary based on local infrastructure regulations and consumer participation. Some thermoplastic like PET and HDPE are more widely recycled and have established recycling systems, like others like PVC can prevent challenges due to the presence of additives. Next point is to promote thermoplastic recycling. It crucial to encourage responsible consumption, improve recycling infrastructures, and invent insights and technology to make the process more efficient and sustainable. Next point is additionally consumers can contribute to recycling effort by properly sorting and disposing of their plastic waste and supporting products made from recycled plastic. Next is circular economy in thermoplastic. The concept of circular economy in thermoplastic relevant to thermoplastic as it focused on minimizing waste, maximizing resource efficiency, and reusing material to reduce the environmental impact. Here is how the circular economy principle can be applied to thermoplastic. Design for circular economy. Design product or packaging with recycling and reuse in mind. This involves choosing materials that are easy to recycle, considering product life cycles, and design for disassembly. Next point is by doing so, product can be more easily recycled or repurposed. Next is recycling and collection. Invents inefficient and comparison collecting and recycling system for the thermoplastic waste. This includes curbside recycle programs, drop-off locations, and initiation of initiative to recover plastic from various sources. The goal is to divert thermoplastic from landfills and incineration and return them to the production cycle. Next is sorting and separation. Improve sorting and separation technology to ensure that different types of thermoplastic are properly sorted. This helps maximize the quality of recycled materials, making them more suitable for manufacturing new products. Next is mechanical and chemical recycling. uh, Explore both mechanical and chemical recycling process. Mechanical recycling involves melting, shredding, and reprocessing plastic into new products, while chemical recycling involves breaking down plastic into their chemical constituent for the creation of new plastic or other chemicals. Closed loop systems. Closed loop systems where products are returned, refurbished, or recycled at the end of the recycles. This approach ensures that the material used in the product are continually restored, reducing the need for big resources. Next is sustainable packaging. We think packaging material to reduce waste and environmental impact. Use lightweight and recyclable thermoplastic for packaging and explore alternatives such as reusable packaging, biodegradable plastics, and compostable material where appropriate. Next is consumer awareness. Educating consumers about the importance of recycling and responsible dispose of thermoplastic, encourage recycling habits and purchasing choice that support the circular economy, such as buying products made for recycled plastic. Next, next is innovation and research. Invest in research and innovation to improve the recycling and process of thermoplastic. This includes developing new technologies, additives, and process to enhance the recyclability and sustainability of thermoplastic. Next is collaboration among stakeholders include manufacturers, recyclers, consumers, and governments in the essential to create a more circular economy for thermoplastic. Sharing knowledge and resource can help overcome the challenges in the recycling and reuse of these materials. And the last point is implementing. Implementing these principles in the thermoplastic industries can help reduce plastic waste, conserve resonance, and lower the environmental impact of plastic materials, contributing to a more sustainable and circular economy. Allah Hafiz.